Today I am going to discuss about particle in a one-dimensional potential box. Or this question can be asked as particle in a one-dimensional infinite potential well. In potential box and infinite potential well is same. Okay, let us prove. Let us consider a one-dimensional potential box of width L. This width is L, and then the potential inside the potential box is 0 and outside the potential box is infinity. Now take Schrodinger's time independent wave equation. Schrodinger's time independent wave equation. It is dou square psi by dou x square plus 2m into e minus v into psi by h cross square is equal to 0. This is the equation. Now apply this v is equal to 0 to this equation. Suppose the particle is inside the potential well, then what happens? Actually the particle develops energy levels. Those are allowed energy levels and forbidden energy levels. Let us find out. At v is equal to 0, when the potential is 0 inside the potential box, then this equation becomes dou square psi by dou x square plus 2me v place in the v place 2me psi by h cross square. Yes, if we substitute 0 at the position of v, we will be getting this equation. This is equation number 2. Now this is a second order differential equation. For this equation we have to consider a general solution to solve this equation. Let psi of x is equal to a sin kx plus b cos kx be the general solution, Here a and b are arbitrary constants and k represents the wave vector and x along x direction are displacement. Be the general solution of equation 2. Now the boundary conditions are x is equal to 0 at psi of x is equal to 0. That means at x, that means at the starting point, the function of the particle is 0. That is, the function is 0 at this first boundary. Then substitute the above values or apply boundary conditions in the equation 3. We get psi of x is equal to 0, that is 0 is equal to a sin k of 0 plus b cos k of 0. This term becomes 0, sin of 0 gives 0, that means 0 is equal to 0 plus cos 0 gives 1, that means b. Therefore b is equal to 0. The secondary boundary condition, second boundary the second boundary condition is x is equal to L at psi of x is equal to 0. Here it's second boundary condition. This is the second boundary, this is the first boundary. At second boundary condition, the function of the particle will be at 0. Now apply the above conditions to equation 3. Then psi of x is equal to 0, that is the equation 3 becomes 0 is equal to a sin kl. Now we have to take the another condition is b is equal to 0. Just now we solved this, plus b cos kl, but b is equal to 0, then a sin kl plus 0 cos kl is equal to 0. Therefore a sin kl is equal to 0. kl, this is. Then if this expression becomes 0, that means a should be is equal to 0 or sin kl should be is equal to 0, but a should not equals to 0. Therefore the second condition is sin kl, that means the possibility is maximum for this expression. Then kl is equal to plus or minus n pi, where n is equal to 1, 2, 3, 4 up to n, so on. Then k is equal to n pi by n. This is equation number 4. Put equation 4 in equation 3 and put b is equal to 0. Then psi of x is equal to a sin n pi by l into x plus 0 at the position of b cos n pi by l into x. This expression becomes 0. Then the function of the particle at x is equal to a sin n pi by l into x. This is equation number 5. Now differentiate equation 5 with respect to x, that is dou psi by dou x, that is this is differentiable, means a cos n pi by l into x into n pi by l. Now differentiate again, that means again differentiate with respect to x, we get dou square psi by dou x square is equal to n pi by l into A. This is minus differential of cos gives negative sine n pi by L into x into n pi by L. It is equal to minus n square pi square by L square into A sine n pi by L into x. This is dou square psi by 2x square. But A sine n pi by L into x gives psi of x. This is equation 5. The RHS and this term is equals. So then dou square psi by dou x square is equal to minus n square pi square by L square into psi. This is from equation 5. This is from equation number. Again I wrote the equation once again. Dou square psi by dou x square is equal to minus n square pi square by L square. Now dou square psi by dou x square plus n square pi square by L square into psi is equal to 0. This is equation number 6. This is equation number 6. Now equate the equation 6 and this equation 2. This equation 6 and this equation 2, or compare equation 6 with equation 2. We get from equation 2, that is 2 me by h cross square is equal to n square pi square by L square. Now we have to find E value, that is energy. We have to find the energy value, that is E is equal to n square pi square by L square into h cross square by 2m. Now simplify this equation. N square pi square, h cross square means h square by 4 pi square into L square into 2m. It means pi square and pi square gets cancelled. Then E is equal to n square h square by 4 into 2, 8 m L square. This is the expression for energy. N means order, where n is equal to order. That means 1, 2, 3 and so on. There is no 0. Order. H, Planck's constant. M, mass of the electron. L, width of the potential box. In the potential well, it develops different discrete energy levels like this. This is ground level E1, this is E2, this is E3. Of course, this is equation number 7. At n equal to 1, at first order, that is E1 is equal to h square by 8 m L square by 8 ml square. Similarly, n is equal to 2, at second order, E2 is equal to 4 h square by 8 ml square, and at n is equal to 3, that is E3. This is third energy level, is equal to 9h square by 8 ml square. At different orders we will be getting different energy levels. Those are discrete energy levels. This energy level E1 is called h square by 8 ml square. E2 is equals to 4 into E1 and E3 is called 9 into E1. That means here this is the first energy level, which is E1. The second energy level, which is 4 times greater than the first energy level, and the third energy level, which is 9 times greater than the first energy level. That means in between there is no energy levels at all. That means these are called discrete energy levels. Now we find the constant value of A of equation number 5. Equation 5, this is the equation. I have to find the arbitrary constant value A by normalization method. Okay, the normalization method is the integral of 0 to L. These are the two boundaries of a potential box. Psi of x modulus of psi of x square to dx is equal to 1. 1 means the probability of finding an electron, which is there is a particle but which is not visible, but we are assuming that there is a particle. That's why by probability we took the final value as 1. Now simplify this equation. The psi of x, put the psi of x value in this equation, we get a square sine square n pi by L into x into dx is equal to 1. That means here the probability of finding an electron value should be unity. That means there is an electron. We are assuming that there is an electron and we are believing that there is an electron. That's why I put this value here. Now further simplify. A square take as common factor. This value 1 minus cos 2 n pi x by L whole divided by 2 dx is equal to 1. This 2 comes here. That is a square by 2 integral of 0 to L 1 minus cos 2 n pi x by L to dx is equal to 1. Means integrate this, we will get a square by 2 into x minus sine 2n pi x by L by solving this equation divided by 2n, that means 2 pi n divided by L within the boundaries 0 to L is equal to 1. It is a square by 2. For further simplification, a square by 2 into x minus L by 2 pi n. This comes to the numerator. This comes to the numerator. So sine 2n pi x by L. This is 0 to L, boundaries is equal to 1. Now this term becomes 0, because if I put L value here, higher order L value here, then L and L gets cancelled. This is 2n pi. If n is equal to 0, that is 2 pi, that means 360 degrees. 360 means sine 0 becomes 0. If n is equal to 2, that is 4 pi, again this step becomes 0. So then a square by 2 into x minus 0, that means if you substitute L value here, we will get L minus 0 is equal to 1. That means a square by 2 into L minus 0 is equal to 1. It means a square L by 2 is equal to 1. Then a square is equal to 2 by L. Now substitute this a square value in the equation number 5. We get psi of x is equal to, at the position of a, that is root of 2 by L sine n pi x by L. The function of the particle at x is this. Here a, similarly a is equal to root of 2 by L. Now I substituted this value here. Okay. This equation gives the waveform of the particle enclosed in the infinite deep potential well. Thank you.